Solution to the SHM pendulum 4-mark question. It is the Juno 5 question 6. So the question says a body performs simple harmonic motion when its acceleration is proportional to its displacement from a fixed point and is directed towards that point. What additional condition must be satisfied for the oscillation of a pendulum to be simple harmonic? And the condition here is that the oscillations must be small. So, I can't seem to write in there. Well, there we go. Small oscillations. This is actually the January 05 question 1. My apologies for that. The pendulum takes 5.72 seconds to swing from A to B. Calculate the period. Well, 5.72 seconds from A to B. Then it's going to go from B to A, from A to C, C to A. So it is, that is half. The central oscillation is here. So it's going to go from A to B and then back to A. It's going to be twice that 5.72. And so it is 11.4 seconds. As ever, don't forget the units. The acceleration due to gravity is 9.81. Calculate the length of the pendulum. Well, we have calculated the period, so we're going to use that. So we're going to say the period is 2 pi rho L over G. So if we square that out, we're going to get T squared is 4 pi squared L over G. And if we then take and rearrange that to make L the subject, we'll get L to be 32.6. And then I'm looking at them saying, I've got 3 sig figs for time and 3 sig figs for G. I've given myself 3 sig figs for the period, which is correct. And so I should have 3 sig figs for the length, 32.6 meters.